Well, this is truly quite the problem. Use Extrema for optimization. I say it's quite the problem. It's this particular problem that is quite interesting, and it takes a lot of patience and some perseverance in order to do that. The degree of difficulty of this I would consider to be high. But it's fun, because once you get to the end of it and you've solved it with that degree of difficulty, well, that's what makes math what it is. And it is actually fun. Well, let's read what we have here. It says a glass candle holder is in the shape of a right circular cylinder that has a bottom and no top. Well, that makes sense. If it's a candle holder, it can't have a top. Candle holder doesn't have to be circular, but many of them are. And it has a bottom, or you're going to burn the place down. And it has a total surface area of 10 pi square inches. Surprised that's not cubic inches, square inches. Determine the radius and the height of the candle holder that will allow the maximum volume. All right, so I know the surface area, and then I'm thinking, well, what is the formula for the surface area of a right circular cylinder that has a bottom and no top? And you may think as a teacher that I may just know exactly what that was, but that would be wrong. I went in and did a search for that, specific to that, and got this formula for the surface area. And then, as I'm reading through this, determine the radius and the height of the candle holder that will allow the maximum volume. And so not only do I need to know the surface area, I'm eventually going to get to the volume. And so I also, in my search, found the volume of a right circular cylinder that has a bottom and no top. Okay, and that's this formula here. Now, in looking at that, I don't know the radius or the height. I do know that the surface area is 10 pi, and that's square inches, but I'm not going to write that right now. And so, okay, what am I going to do? Because in both of these formulas, in order to solve this, I'm going to need to know the radius and the height. In fact, I'm asked to even find the radius and the height. And this little thing here, but where it says maximum volume, gives me a clue, and in particular, since I'm in a chapter or section on Extrema, then I probably need to find we're going to find that by graphing it and finding the Extrema of a variable x. Now, I've got to make a decision here. I need to take this surface area, something that I know, and I need to solve it for one variable so that I can substitute that in to the volume formula in order to graph it for what would still be an unknown variable. So let's take this surface area formula and let's just solve it for height. I could solve it for radius, for r, but I see that r squared, and I don't know if that may end up making me take the square root of something. I didn't work it that way. I solved for h. So if we got 10 pi, and that equals 2 pi rh plus pi r squared. Well, I can factor out a pi r of this expression on the right. And when I do, I've got 10 pi equals pi r times 2h plus r. Factoring out pi r. Now I can divide both sides of this equation by pi r. And so now we got 10 pi over pi r equals 2h plus r. Well, my pi's here can cancel, so I'm left with 10 over r equals 2h plus r. And let's subtract r from both sides. So now we got 10 over r minus r equals 2h. And then I could divide this, both sides of this, by 2, or maybe perhaps what I want to do is multiply everything by the reciprocal of that 1/2. And so then I could say that 1/2 times 10 over r minus r equals the height. And so now that I've got that, I'm going to move over here to this volume formula, and I'm going to substitute in this expression for h. So when we do, then I would have that the volume is equal to pi r squared times 1/2 times 10 over r minus r, which is what I decided that h is equal to. All right, now we're going to move over here to the calculator, and we're going to enter this equation in, and then once we do, we're going to use our calculator, our calc function, to find the extrema, which is going to give us two things. It's going to give us a value for for r, which we're going to substitute x in, and it's going to give me the maximum volume of this candle holder. And then all I got to do is find a value for the height. All right, so are we ready? Doesn't matter if you are or not, we're going for it. All right, well, I'm over here on the calculator, and I have entered the equation that we found that we using for volume, substituting 1/2 times 10 divided by radius r, which I substituted for x since I'm in the calculator, minus r, minus the radius. And it's a little bit tricky to enter. You might want to pay attention to how I did that. I put in parentheses the pi r squared using x for r, and then I put in another parentheses and embedded in it a second parenthesis, or actually two parentheses. So I got 1/2 times 10 minus x, and notice I put the 10 divided by x, in parentheses, minus x, remembering again now, I'm substituting x for r, and then I'm going to go to the graph screen. Now, I can see that I've probably got an extrema up here in the first quadrant, but I can't see what it is. So I'm going to go to the window, and I'm going to make an adjustment on the Y max, because I'm looking for maximum. I'm going to try 20 and see if that helps. We'll go back to the graph. All right, well, now I can at least see this point of extrema right here. Now, I'm going to use the calc function, so I'm going to hit second trace, which is calc, and I want to find the maximum. And this is going to give me two things. This is going to give me an x value at that point of extrema, and it's going to give me the y value, which is the extrema itself, and in this case is going to be the maximum volume. So I'm going to choose option 4. And then I say I need to scroll. Yeah, there's my little cursor. So you see down here it says left bound. I want to get it just to the left of the top. That looks like the top right about there. So I'm going to go to the left of that, and it says left bound. I'm going to hit enter. And then it says right bound. So I want to go just to the right of that apex. And I'm going to say right bound, okay. And then it says, hey, you want to take a guess? And I say, well, sure, why not? And I hit enter. And then I can see that where x maximum, and I remember this x is the radius in this case, the problem that we're working on, and I'm going to jot this down. It says it's 1.8. I'm going to round it to the nearest hundredth, 1.83, and that would be in inches. And y, which is the volume, remember y equal, we had volume equal all of that, 19.12. Okay. So my maximum volume would be about 19.12. All right, now that I have found something for the radius, I'm going to go back into the equation for the surface volume where I had known of 10 pi, and we're going to solve for the height. In fact, let's see. How might I want to do that? Well, okay, we'll just solve it that way. All right. Meet me back on the other side. All right, if you recall when we had that the surface area formula, which was S surface equals 2 pi radius height plus 2 pi radius squared. When we solved for h, we came up with this formula right here. And as we just went in and looked at and solved for Extrema, where we found that the radius was equal to approximately 1.83 inches, and the volume, even though we're not asked to even describe it, was actually, I think, 19.12. If I go back to where I solved in this formula for h, I can substitute in this 1.83 for r and get us our height. So we're going to say h then is equal to 10 over 1.83 minus 1.83, and all that's divided by 2 or multiplied by 1/2 as the case may be. All right, so let's see. Let's say 10 divided by 1.83, and that comes to 5.4644, and then we're going to subtract from that 1.83, which is 3.6344, and then divide that by 2 for our height, and you can put all that in your calculator if you care to. We come to the height being approximately equal to 1.82 inches. Now, that was, again, quite the problem. I had to go in, I had to find two formulas, I had to solve for a specific variable, then I had to turn around and graph that into the volume formula, using the volume formula, so that I could get a graph and then estimate what the maximum extrema was to find for both the radius and the volume, radius being x, and the volume. Then take that radius, that finding for radius, go back to my original formula for surface, and I could have put all that in. I really just kind of shortcut it where I solved for h right there, just to make it a little bit easier so that I could find the height. Isn't math delightful?